Hello class, I'm working out of your Algebra 2 book 7.8 radical functions. We'll be on pages 319 through 321, and there's a chart that we will need on page 320. We'll be going through parts of the chart as we go through examples. So to begin, if you're given a parent function of the way a certain graph is visually graphed on the Cartesian plane, such as y equals the square root of x, then we're going to be thinking about what this looks like visually on the Cartesian plane, what is its domain, and what is its range. Right away we can see the domain and the range should be somewhat positive because of the root symbol. Otherwise it'll throw an imaginary number. So that helps right away. To graph this function, remember that we can plug in values for x to see what the y value will be. We've done this before. And at -1, that would be an imaginary number. At 0, we would have 0, the origin. At 1, we'd have 1. And at 2, that would be the square root of 2 on the calculator. That's approximately 1.4. So our apparent graph looks something like this, where the domain will be all of the x's such that x is greater than or equal to 0, and the range will be all of the y's such that the y's will be greater than or equal to 0 in this y equals the square root of x. So knowing that, we'll be given a function that we're going to work with that looks like f of x equals a times the square root of x minus h plus k. And this function has parts. Each of these parts throws a new rule as to what happens to the parent function. So a, in being positive or negative, will be addressed, the radicand will be addressed, and the k will be addressed, and what the new graph will look like. So looking at the absolute value of a greater than 1 makes the graph steeper. And when the absolute value of a is a fraction, it makes the graph flat. And when a is less than 0, it reflects the graph across the x-axis. So like an image, a mirror image, and it reflects. When we address the radicand, x minus h, h translates the graph right or left. And when we address k, it simply shifts the graph up or down based on whether it's positive or negative. So that's an easy one. What does all this mean? Let's look at examples. If we're given a function g of x equals the square root of x plus 2, then we're going to see from the parent graph we have a shift up or down for the k value of a positive 2. So the parent graph, again, was this, something like that. Let's see what happens. And plug some values in for x to see what the square root of x would be. Plus 2. So at 0, we'd have a 2 for the y. At 1, we'd have a 3 for the y. At 2, we'd have something like 1.4 plus 2, 3.4 for the y, and our graph starts emerging. So we see that this graph at 0, 2 shifts up. It looks something like this from the shift. Shifts up 2 units. And then the parent graph to the new function shows that shift on the actual visual in the plane. If we're asked for domain and range for the g of x function, we have domain will be equal to all the x's such that x is greater than or equal to 0, just like the original parent function, because it starts at 0 on the x-axis. But the range changes. There's nothing in the range below 2. So we have all the y's such that y is greater than or equal to 2 for the domain and range. We want to address what's under the root symbol and see what happens to the parent graph on the shift. It's really cool. We can take our radicand and set it equal to 0. We're going to get x equals 1 and kind of double duty. In graphing, we also throw the domain, what it is. So domain right away from setting our radicand equal to 0 is all the x's such that x is greater than or equal to 1. Just from that information right there. Alright, to graph, we want to check it out, see what happens. We're going to say, well, we can start with a 1 for x. We get a 0 here. A 2 for x, we get a 1. 3 for x, we get a 2. Under the root symbol, that would be the square root of 2, which is about a 1.4. And to graph this, we would start at 1, 0, and then it goes to 2, 1, and it looks like this from our parent function. Alright, so now the range here are all the y's. So all the y's such that y is greater than or equal to 0 in this graph. If we get a function that has a lot of shifts, reflections, and transformations, then it's going to have to be addressed in parts. So for instance, if we have negative 2 for the a, square root of x plus 3 plus 1, then we address all the parts of this function. Our graph on page 320 will help us. We can determine the domain from the radicand right away. We can set it equal to 0 to help us. We'll be asked for domain. So domain will be all the x's such that x is greater than or equal to -3, so our graph should reflect that. It's a great start. We can build an x and y chart just to help us. We have a certain x, and we plug it in for our function value. Let's see what we'll get. So just determining where to start under the root symbol, we could start with a -3 because we can work with a 0 under the root symbol. So a -3, mental mathing that, would be a 1. A -2, mental math that, and throw a -1. A 0, be about a -2.4. A 1 would be -3, and so on. So if we plot this from the parent graph, which looks something like this, from our chart, we determine that the A value less than 0 reflects across the x-axis. Alright, so we're going to have something happening across the x-axis when we graph. And we determine that the h value translates our graph left or right, and we found our domain for x. It's greater than or equal to -3. It's almost like graphing with absolute value. It's opposite what you'd think. It says a +3 under the root symbol, but we are going to graph on the negative side of the x-axis. So the h translated our graph left 3 units. Then the k value just shifts our graph up or down a unit. It's a +1, so a unit. So let's see what this looks like and whether all of the rules for our function apply. We'll check them out again after we graph. Okay, at -3, 1, we have a point. At -2, -1, we have a point. At 0, we have approximately a -2.4, and at 1, we have a -3. Our graph's emerging here. And that's just freehand. It's probably not perfect. And let's make sure that we're addressing this correctly. It's starting at this point. Okay. So we see from the -2 that we do indeed have a reflection across the x-axis for our graph in this function from the parent graph. We also see that the graph shifted up a unit for the k from the origin. Okay, so that did happen. Cool. And the x + 3 under the root symbol made our domain be equal to anything x greater than or equal to -3. And so just in freehanding the graph, may not be shown here, but it is across right here at the -3. Go down just to redo that. All right. So in graphing this, we have addressed all the parts of the function, and we see what happens to the parent function when we graph it based on the values in our new function. Also, the last thing to remember is that when the absolute value of a is greater than 1, the graph should be steeper than the parent graph. So that's a fourth idea to determine. Well, we have the absolute value of -2 in this graph from the a value over here at -2 is greater than 1, it's a 2, and so we should address that this graph should be steeper as well. So several things happened here. To recap, the -2 made the graph steeper. Also, the fact that a is less than 0, the -2 is less than 0, reflected the graph across the x-axis. The h value translated the graph a -3 from the parent graph, and the k value shifted the graph up 1 unit. So 4 ideas happened from this function. So be sure to address all of your values and what they will do to the parent graph function, and make your chart. Also, we'll be using the Desmos calculator. I will regraph these ideas plus another example from your section in a subsequent video on Desmos to help you. And we will look for setting two functions equal to each other to determine an intersection point of those two functions. When we set two functions equal to each other, we get a solution. So we'll look at that on the calculator shortly. So pick up that video as well. It will be short. I hope this helps, and I'll see you soon.